What a day! What a day! The problem was to debug, to understand what was the problem that I was having. And I was having multiple problems actually. First of the, like you've seen already, my first try, my first circuit that I did, it was a absolute crap. It was absolute garbage circuit. I did follow the, like a monkey, the circuit that I made in Proteus, the simulation, but I didn't keep in mind that this is, I use different flip-flop circuit. This is a D flip-flop, and what I use here, I will use the JK flip-flop, which is a different flavor. And I had to do this circuit here. Pretty much I put to ground a couple of pins, which one, I don't have the circuit here, but I draw it here very quickly. This, let me point it, I hope you can see it, yeah, I can see it. This pin 3, 4027, so pin 3 is clock number 2, is the clock pin. So I'm clocking the chip through a wire, through this wire actually, on pin 3. And on pin 1 is the same, it remained the same, one LED and one resistor, 1 kilo resistor and one LED here, on pin 1. On the left, here is a jumper, you don't see it, you cannot see it probably, because it doesn't have a plastic cover, but it is only the metal wire between the last two pins. So here and here, these last two pins are jumped by that wire, and only one single visible color wire is to the ground. So 3 pins I had to ground. So these 2 pins, set to reset, and the VSS, which is actually the ground pin. So the ground, the set, and the reset pin, I had to ground them, and that's it. And it worked. It when I put a signal on the clock, when I was clocking the chip, I was giving a signal. It was flip-flopping the LED. It was opening and closing the LED. So I took it out from here. I put it here. I did a test until I look on internet. I find a good circuit, a very common circuit actually for this chip, and I applied it, and I got the good result. I put it back, and then I knew it was working correctly. But the next problem was this guy here. The next big problem. Which is the binary counter, this guy. Yeah, I was getting a lot of vibration in the LEDs. When I was pressing, it was appearing like it was random. The LEDs was appearing like they were switching randomly from the output of this chip. And I debounced the button that I had here. I switched another button, a brand new button that I have. I can show you actually. This is my box with buttons. So here, this kind of button I put. This kind of press button, and you can hear it's clicking. It's very decisive. It's brand new, absolutely brand new, and extremely good quality from China, from eBay or AliExpress. I don't know which one, but yeah, it's very. They are extraordinarily good. Actually, I repaired a monitor button. It was having a lot of problem. Also, the debouncing was of the button. It was fucked up. The button was getting old on that monitor, and I put a brand new button like this, and now when I'm clicking, it's creating that click perfectly on the monitor. Now when I'm closing and opening the monitor, it is absolutely perfect. And it's my monitor that I repaired. It's a very old monitor, but yeah, it did the job perfectly. This brand new, and I trust them with my life. I mean, I know they are doing great job. And I put that brand new button, and I've seen an improvement, but it was still creating a random switching here. It wasn't perfect yet. Then I had this capacitor, 474. It means I think it's 4. Yeah. It means half of 1 microfarad, so 470 nanofarads. And I had this in the beginning, and then I switched. After I made that first movie, I switched with 1 microfarad, then with 10 microfarads, and I've seen an improvement. Small, extremely small. Improvement, not that obvious, but by switching back and forward, I was able to see the difference, and I was drawing the conclusion it is better with a larger capacitor. And when I switched to 10 microfarads, difference was a bit more clear, and then I switched to 100 microfarads and then to 200 microfarads, and it was still the LEDs were jumping around, but not as fast as they were before, of normal behavior, of normal switching from one bit to another bit. And then I figured out that I need a debounced button. So that's how I process everything. This is how I'm debugging and I'm thinking. This is my logic. So I go to the internet and I find a circuit, my favorite integrated circuit 555, that is helping. That is getting me out from troubles a lot of times. When I don't know something how to resolve it, I'm searching for a 555 circuit that can do that thing, and usually they can. It's a timer, and everything that is related to a timer, even if it's only 1 pulse, it can do it. And in this case, is only 1 pulse of 100 milliseconds. It says here with the values that I have they have here, but I switched this capacitor actually. This is the board. It's a very cute board, and let me show you how it's working right now. It's working absolutely perfectly when I'm pressing 1, 2, 3, and that is commutating 1, 2, 3. Unfortunately, unfortunately, as you can number with me and you can hear me number, it's only switching, it's only counting to 3, this counter that I have here. So the problem is not yet resolved. For some reason, is not counting to 7. In the simulation that I made, everything worked perfectly. What you see here on this diagram that I have behind everything, behind my real thing here, here with all of this worked absolutely perfectly. But now in reality, probably I miswire something. I don't know. I will have to find out what was the problem with the counting. But right now it's counting only to 3. But what I'm telling you, what I'm showing you right now is this debouncing circuit that is transmitting a pulse, a very short pulse. Doesn't matter how long or how short I'm pressing the button. If I'm doing this or like this, like an old man, you know, like you know, or very quickly, if I'm doing this, so this is normal and is doing with a slight delay. You see, the moment I'm pressing is taking a little bit of time to actually execute the command because of that capacitor. And I played with that capacitor, this capacitor here. This originally is 1 micro, but it was also switching too quickly. This is a bad button. It's a very used button. Probably it was the button from the monitor that I took it out. And it's having bad contact, so it's jumping, is doing multiple contacts when I'm pressing. So I had to switch this capacitor value to greater. From 1 micro I got to 16 microfarads, and it was too larger delay. And right now is 9 microfarads, or around 10, less than 10 actually. Is 9 or 8 microfarads because these are SMD, and I actually checked them with my multimeter, and I got the value by actually physically checking it, and this is working pretty normal. You know, not too idiotic delay, too much delay, not very fast that it can bounce again, that is permitting to the fucker to bounce around again. So now I have to, so right now it is working, this part is working, not 100% because I have to resolve the 7 counting, to count to 7. And that was very unexpected. I didn't expect it to get this problem with counting. And yeah, but I'm happy that I resolved this in one day. I made this little board. Let's see if I can actually zoom in into it because it's very cute. Let me take out this ugly thing from here. So that's the 555 SMD 555. Actually, I built it upside down like this. I built it like this. This is the way I make it. But I'm using it upside down. I switch it like that, and it doesn't matter really. But I'm showing it to you. It's practically this circuit. Only difference is that capacitor that I changed the value, and that's it. All the wiring is the same on that board. And this, if you didn't catch it, this is ground wire. This wire here on the bottom is the ground, and there is the plus 5 volts to 15, but it's not necessary. It's only 5 volts what I'm doing here. So this is it for this part, which is still troublesome, but I will resolve it. I will resolve it. So yes, this is it for this part. Thank you very much, and I'm expecting you later. Bye bye. Yeah.